As Chris introduced me, my name is Haresh Moradia, and I am a staff engineer at FANUC America Corporation. We're located here in Rochester Hills, Michigan, and we are the North American headquarters for FANUC Japan. Quick background on me. As a staff engineer, I'm responsible for the product management of all safety. As Chris mentioned, I have over 31 years of experience across the automotive and robotics industry with educational experience across 2 universities and holding 3 degrees. My hobbies include constantly learning new technologies and how they would apply to FANUC and engaging with customers with our latest offerings, and that's why we are here today. Additionally, when I'm away from work, I fill my time doing martial arts, and I'm currently working on my 3rd-degree black belt in karate. First, if you have not heard already, I'm excited to share the news that FANUC has just released its new R50IA controller, as seen here on the right. Currently, we have 3 different cabinet sizes, which include the A cabinet, the B cabinet, and the mate cabinet. The main board, too, has a new look and is illustrated here on the right. But even more exciting is that I get to introduce 3 new software options: Software PLC, the operator panel, and process access control. And to top it all off, these new software options utilize CODESYS on FANUC robot controllers, which I think everyone here in this room is well familiar with. Please note, as Chris mentioned, that we will take all questions at the end of our session, so hang in there. The 3 different software options and the respective ordering information are summarized on this slide for future reference. FANUC users will have the ability to select any of these options and each build upon one another. That is, to use Software PLC Operator Panel or Process Access Control, users must have the base Software PLC option. This means that both the Operator Panel and Process Access Control are optional. Software PLC integrates the PLC in the robot controller, and this means no additional hardware is required because it uses the existing Ethernet ports on the main board. This allows the execution and control of the robot system by executing robot programs and controlling the peripheral devices. Users can generate programs within CODESYS, transfer them to the robot controller, and then execute these programs to control peripheral devices, and then allow operations to be seen on web browsers, teach pendants, tablet teach pendants, and drumroll please, our latest new lightweight pendant seen here on the right. The operator panel is an optional software option that allows users and integrators to take advantage of creating customized operator panels that allow the visualization of panels on browsers, pendants, and PCs. The key advantage of this is that users can monitor and operate the status of PLC applications in real time at their fingertips if they are on a teach pendant, and they don't need to walk back to some hardware-mounted stand housing and displaying a display panel to perform an operation. Literally, the control and visualization is at your fingertips. The third piece of this exciting software is the process access control option. This feature will allow users to connect amplifiers that use the CIA 402 drive profile to be connected as EtherCAT subordinate devices using CODESYS EtherCAT soft motion. This feature will support control modes such as cyclic, synchronous position, velocity, and torque modes. Again, the major advantage is that all 3 options are designed within CODESYS development system for ease of use. The first software option that I want to go into detail about is the Software PLC. This is the minimum software that's required to create programs within CODESYS and deploy the code into the robot controller. The option order number for this item is A05B-2700-621. As I mentioned quickly before, this option integrates the PLC inside the robot controller to execute programs sequentially. This permits the control of peripheral devices and follows the guidelines outlined in IEC for PLC programming. Users can create sequence programs using CODESYS v3.5, Service Pack 19, or latest, along with FANUC-developed CODESYS control for FANUC robot package. The package level currently is at 1.0.4.0. Software PLC supports up to a maximum of 5 cyclic tasks with intervals that can be configured and adjusted from a minimum value of 2 milliseconds up to a maximum of roughly 100,000. In terms of memory capacity, a PLC application can be up to 6 megabytes in size, where program code and data memory capacity are set to 3 megabytes each, respectively. Assuming 2 steps per line, we're talking roughly up to a maximum of 180,000 rungs of ladder logic. The input and output areas can utilize up to 640 words. And additionally, 6 programming languages are supported and include structured text, function block diagrams, ladder diagram, sequential function charts, continuous function charts, and instruction lists. Additionally, the latest software feature now has the ability to select where files can be saved, and which include the FROM memory, a memory card, or USB, as shown here in the lower right. Additionally, software PLC contains the following supported libraries. By default, the standard, IO standard, breakpoint logging, CAA device diagnosis, and 3S license are included. SFC includes the IEC SFC and analyzation tools. Previous platforms used PMC for internal PLC programming, which required special software to be purchased from FANUC. This special software had to be installed on a computer, licensed, and didn't offer the items discussed on the previous page. Note, PMC is not being eliminated. Heavy users will now have the ability to use software PLC using CODESYS to generate code at a more higher programming language, as we consistently see through the various educational institutions where the programmers are utilizing more of the structured text for their programming needs. Though users of PMC who are excited to transform their code in the future can see here that the architecture between PMC and software PLC is in very close alignment. This is important because it provides a good transition for our current users of PMC to gracefully transition into software PLC. In terms of the internal and external I/O assignments, users of PMC will see a very close alignment on how data will be mapped using software PLC. As clearly demonstrated here, there really is no difference. But again, it's important because it will help current users of PMC to slide right into using CODESYS based on the software PLC option. Both internal I/O and external I/O can be mapped as illustrated on this page. Internal I/O assignments are those that allocate signals to and robot controller, and these can include data types such as digital I/O, group I/O, and the user operator panel I/O. External I/O allows users to take advantage of external device control. That is, if a user has peripheral devices on either Ethernet IP or Profinet, these peripheral devices, their I/O can be used within the CODESYS programming environment. Basically, you can write code in CODESYS to control the robot peripheral devices, such as turning on a conveyor or gripping a part, etc. On this slide, this is an example of some mapping of internal I/O. Here we can see that 120 bytes of I/O were created in CODESYS IDE, and they are mapped to both the digital inputs and outputs respectively. Note here that the software PLC rack is going to be identified as rack 110 for both digital inputs and outputs. In this slide demonstrates how both inputs and outputs can be triggered. On the left side, we see that the CODESYS IDE is forcing some random output signals as denoted by the %Q addresses. These outputs are registered as digital inputs based on the mapping on the previous page. Likewise, digital outputs can be turned on the robot controller, which then trigger the respective %I addresses within the CODESYS IDE. Additionally, peripheral devices such as those mapped here on Profinet can be controlled by CODESYS. Here we see an input module on rack 99, slot 16, has a proximity switch, and it is currently turned on. External I/O assignments allow users to take control of peripheral devices, and they can be observed as digital inputs, as seen here in this example. It should be noted here that inputs that are mapped externally cannot be simulated. Here we see an example in an attempt to simulate an input that has been mapped externally. Note on the right side in the CODESYS IDE, the simulated input is not turned on. And this is because the peripheral device has been mapped as an external device and it is going to be used by the CODESYS IDE. Please note that these signals can be used in TP programs, but just not simulated or turned on by TP logic. Likewise, digital outputs can be turned on in CODESYS to trigger the actual device output modules. Here we see 3 consecutive Profinet output modules are being controlled by the CODESYS program, which turns on the respective outputs. It should be noted here that when this data is mapped to the CODESYS, these outputs cannot be turned on by the robot controller. However, just like before, we can still monitor them inside the teach-pendant programs to satisfy conditions that would be used for the next steps. Here in the old PMC environment, you can see that users were limited only to ladder logic. At its time, it was powerful for major customers and especially the automotive OEMs. However, sophisticated programming languages are being used throughout the industry today. And to address this, the CODESYS system allows programmers to take advantage of ladder programming in a similar environment, again, helping our PMC users transition to the CODESYS software PLC. Here we see an example where the user has defined some variables in a program. These variables are then mapped to the respective FANUC robot I/O. A simple ladder rung is shown here where a digital input turns on a digital output. The power of the programming is increased as the toolbox in CODESYS offers more tools, which include a variety of operators as seen on the right, such as Boolean, math, and other operators, as well as the capability to use function blocks and ladder elements. Now, advanced programmers can take advantages of other languages as well. Here we see a user has created a program using structured text. In this case, when a digital input is turned on, a counter has begun to increment. Users can take advantage of this type of programming to create powerful code and make it more efficient. An example of such powerful coding is seen here. Here a user has created a function block called start program. Advanced programming techniques like this enable users to take advantage because they can now call these functions to start programs over the UOP interface as demonstrated in this example. Software PLC is the perfect option for advanced programmers who are not requiring PMC internal assignments such as info, user alarms, welding interface, wire soldering detection, or safety PMC. In those cases, users can still use the PMC software. However, users must choose between the two because both are not supported at the same time. However, if users want to program non-ladder and use advanced programming techniques, then software PLC using the CODESYS development system is the perfect solution. To summarize, the benefits of using software PLC include the following. Reduce costs because a PLC is no longer required. And I think a lot of our customers are going to enjoy not paying those extra dollars for external hardware and PLCs. Also, this software option now offers a modern programming environment with up to 6 programming languages, so it increases flexibility on how our advanced next generation programmers can use code more efficiently. It also gives you the ability to control peripheral devices and execute programs. And again, since this is closely aligned to PMC, there's not a major obstacle in learning. That is, people who are using PMC today will be able to slide right into CODESYS development system smoothly. And if they choose to still stick with the ladder programming, they'll still have that capability. In terms of applications, this is going to be ideal for material handling, pick and place, conveyor control, and palletizing, and a lot more. But wait, there's more. In addition to the amazing CODESYS development system for software PLC on the robot, there is yet another new option that will be integral to software PLC, and this option is the operator panel. The software PLC operator panel, order number A05B-2700-S640, and this is the window or looking glass to create the interface that allows the interaction between the code and the operator. A visualization that can be accessed in multiple locations, as we will soon see. The operator panel web visualization allows operator panels, such as the one we see here on the right, to be developed in CODESYS and then deployed and accessed across web browsers, teach pendants, tablet teach pendants, and even the new lightweight teach pendant. This option brings the HMI literally to the palm of your hands and requires the software PLC option discussed previously. The CODESYS control package for FANUC Robot 1.0.4.0, and additionally, it does require the software PLC operator panel option. Web visualization and operator panel display allow the monitoring and controlling of screens remotely on teach pendants or web browsers. The amazing part of this development is that both the PLC program and operator panels can be developed at the same time within CODESYS and tested within that same environment before deploying them out into the real world. This is done relatively quick and easy by assigning PLC program variables to pre-designed visualization elements. Development will be quick and easy because they can quickly drag and drop from the visualization toolbox using the GUI editor in CODESYS. This permits integrators to quickly create screens that can be developed once and deployed across many, and thereby improving both development time and project deliverables without spending extra dollars for hardware associated with HMI installations. Visualization tools contain a number of icons to select from. These categories include some basic common controls, measurement controls, lamps, switches, bitmaps, special controls, as well as date and time controls. These predefined elements reduce the amount of time invested by integrators in creating simple operator panels. Once the screens have been developed and tested within CODESYS and deployed, they can be accessed using the URL string seen here. It's important to note that the Visu task defaults to a priority of 31 with a cycle time of 100 milliseconds. Once it's deployed, any browser can access the operator panel. This example shows the operator panel being accessed by a PC to look at the R50IA controller UOP panel. We can see that the command ready is on and that the program is paused, but there is a fault because the teach pendant is enabled. We also see that the robot override speed is set to 50%, and that program 1 has been loaded. And if time permits, we'll try to conduct a live demonstration of this once we've gone through this webinar. And here I have a video and a demonstration of this in action. You can see here that the operator panel is accessed using the address described on the previous page. As the demo toggles through the buttons, you can see that it creates some faults, as well as we can adjust the speed. And you can see the actual robot code controller updating in real time the percentage that we set that override to. The response times are amazing, and this type of control is going to be a game changer across the industry as we deliver a functional operator panel to any device that supports web browsing and take the users away from installing multiple HMIs across cells, because now you can access these web panels, operator panels, from any web browser. I'm going to let this play just a little bit longer so the audience gets a good sense of the control. And I'm going to grab me just a quick drink of water. Here's another example of an operator panel showing a different layout and work cell interaction. Here, our designer has created an R50IA demo showing the work cell, cell status, and production status. Imagine creating this screen one time and deploying it across multiple robot controllers throughout your facility. It significantly improves your integration times and it keeps the consistency of the program the same. You can see here the layout is slightly different, but that is one of the amazing thing about programmers. They're like pool players, and there's a million ways to make a shot in pool, and it's up to the programmer to choose the shot that's going to make them the winner. Additionally, in this design, you can see that a robot IO pop-out page came up, which allows the users to quickly see what UOPs are active and inactive, and then also allows the users to visualize which digital inputs and outputs may be active. So CODESYS software PLC with operator panel web visualization is going to be a major game changer with many benefits. For starters, users can reduce the costs because no additional hardware is required for a physical HMI. Programming is easy because CODESYS offers a built-in visualization toolbox, which is ready to use with a variety of pre-designed elements can be accessed by any web browser or teach pendants that I described before. And dynamic testing of all operator panels can be done immediately just within the CODESYS development system. Again, a major game changer for both users and integrators using both the software PLC and operator panel. But wait, there's even more. Now users can take advantage of yet another new software feature. And this feature is the software PLC process access control software option A05B 2700 S641. So process access control allows the control of position, speed, and torque of process access. FANUC robot controller, built-in Ethernet ports via EtherCAT soft motion within the CODESYS development system. This option utilizes the PLC open motion control function blocks and requires software PLC and process access control along with the CODESYS control package for FANUC robots. The operator panel can be installed optionally and is not required for process access control. That is, you can just use your process access control with the software PLC without an operator panel. Process access control uses EtherCAT soft motion, where the CODESYS implements an EtherCAT master. Any EtherCAT subordinate device that supports amplifiers using the CIA 402 drive profiles can be connected, but control modes will differ based on the vendor selected. Control modes include cyclic synchronization of position, velocity, and torque modes, and again, these will be dependent on the EtherCAT subordinate device. It's important that we note that with process access control, this operation is asynchronous with respect to robot motion. That is, for example, the run LED is independent, program running and busy are not tied to process access operation. E-stop functions will not stop the process access. A fence open or switching to T1 or T2 mode will also not impact the operation along with the servo off input. And likewise, the hold function has no impact on the process access. Now, even with that said, our advanced programmers, however, depending on how they write their logic and code, this can be possible if they condition their logic to start and stop those external devices. But it's important to note that programming techniques would be required to make that happen, and it's not controlled by default by the robot controller. The process access control requires selection of process data. Here you can see the variety of PDO mapping that is available on the Keyence SV3 servo drive. Both the outputs and inputs must be selected for use. The process access control contains the basic SM3 basic library that includes function blocks, and the details for each of these can be found by pressing the link here for details. I'm not going to click it here, but these slides will be made available, so you will be able to click it when you get the PDF format. Function blocks include the administrative, diagnostics, movement, as well as the parameter access. So in preparation, a user must first add the EtherCAT main device or master. After this node is installed, specific drives can be added by locating the EtherCAT subordinate device ESI files. Then the process access can be added and then configured. The EtherCAT main device must be defined. That is, in CODESYS, it needs to be configured so that the correct port is identified on the robot controller that will use the EtherCAT motion. What's amazing about the CODESYS development system is that it knows which port MAC addresses are defined on the robot controller. So therefore, the user must match the MAC address with respect to the port number on the robot controller that will be used in CODESYS as the EtherCAT master soft motion. And this is done by setting the source address to match the port address on the robot controller as seen on this page. Process access control supports EtherCAT subordinate devices that support the CIA 402 access profile. These devices can be added to EtherCAT master soft motion manually or by scanning for devices if they have been connected to the network and their respective ESI files have been installed. Once they are detected or manually selected, they can be added as soft motion CIA 402 access, and the respective process data can be checked off as seen here on the bottom of this page for the Keyence drive. Once a process access control has been added, the parameters must be set up using the General tab. This screen here shows parameters such as access type, motor type, velocity, as well as the dynamic limits. Set these parameters according to the motor and drive selections that are being used physically. Additionally, both the scaling and mapping can be set up and configured. And this includes the motor turns, gear output turns, as well as units for the application itself. Once these elements have been successfully configured, the operation can be tested. And now, let's bring it all together. That software PLC, the operator panel, and the process access control. In this video, we are using a Keyence SV3 servo drive and motor series. Specifically, we are using the Keyence SV3 020L2 servo drive and the Keyence SV3-B020AK. Though I'm unable to show the physical servo drive and motor sitting in the lab, this demonstration will show some of the key features within CODESYS development system that can be used for testing, such as monitoring motor. Note here that in this example, this is CODESYS version 3.5 Service Pack 21 with patch 3. I'm going to let this video play and try to highlight some of the key features as they're being demonstrated in the video. Note here that I'm testing in CODESYS the operator panel, which we mentioned earlier is a major game changer because users don't need to physically test it on the device. They can actually test it within the CODESYS development system. And at the same time, we can access the robot controller's web visualization via a web browser, and both have control over the motor. I'm also highlighting the I/O that I've turned on in CODESYS so that the controller is in auto mode. Those signals are the immediate stop, the hold signal, the safe speed, and the enable. Again, if time permits, rather than looking at this video, I'm going to attempt to show a live demonstration of this as I have all this material configured in the lab, and I will be accessing it remotely. Another game changer. So now I'm asking everyone in Intensifier that CODESYS development system can be used to program the latest software features such as software PLC, operator panel, and process access controller on the R50i robot controllers, starting with version v10.10, P25, or latest software. As I mentioned, all three are not required for programming, and at its core, software PLC, software option 621, is required minimally. Both operator panel and process access control are optional. However, as we just all saw, all three working together at the same time bring out the best of all worlds, especially when controlling process axes. Users and integrators will immediately realize the benefits of these options as it will reduce both the hardware and software costs by limiting the needs for external PLCs and HMIs. And in terms of software, only one is required. That's the CODESYS development system, whereas other systems require software for the PLC as well as software for the HMI. In terms of engineering costs and time savings, this immediately is realized because users can now develop their system one time and then they can deploy them across many, thereby improving quick integration times and turnaround. Additionally, programmers will be able to use advanced programming techniques, which in the past was limited by our older version of software, PMC, because since they were limited only to ladder logic. And EtherCAT soft motion using the CIA 402 drive profiles will increase flexibility in drive and motor selections that allow the control of external third-party motors. A diversity of motors can be added as EtherCAT subordinate devices that comply with CIA 402 and no longer limit users and customers to just FANUC drives and motors. It opens again, another game changer where the user is now open to any third-party motor and servo drive to control that process control axis. Here are some beneficial and helpful links that I've included. For any follow-up questions or additional questions that you may have, I've included my email address. I've also included here a link for downloading the package. You can just simply click on that. If you're a registered user today on our FANUC site, you'll be able to download that CODESYS package. And additionally, we have several series in our FANUC Tech Short site, which give users access to a variety of techniques and how-to lessons on how to use other products. And soon we will be posting the software PLC and some of the things that we mentioned here today. And then finally, we have a resource in our FANUC Friday webinars where if you're an authorized system integrator, you'd be able to access full videos on how to set up certain applications that you may consider using. And then before I conclude for this session, and before I show some demonstrations, I wanted to thank the team at CODESYS who were instrumental in working with FANUC and achieving greatness. Special shout out goes to Tim Gustin, who without his support, this would not have been possible, along with his great knowledge of CODESYS. And at the same time, a shout out to Jeff Nimtz, who, along with Tim, shared both helpful and beneficial techniques in programming. And special thanks to Chris, to whom none of this would have been possible. So thank you all so much. And additionally, I want to give a shout out to Lucas McGuire, who was able to get us the drives and motors to demonstrate process access control, and Showa Shiba for introducing us to the EtherCAT motion devices using CIA 40, using key and servo amplifier SV302, OL2, and the servo motor SV3B020AK. Again, and none of this control techniques would have been complete without the assistance from Henry Hiroaki Yanagi, who assisted in how the drive parameters for the motors need to be set up. Again, thank you all for the support and making this all possible. Now I'm going to briefly stop sharing my screen, and I want to really quickly show an example, if possible, of the in action. So give me 1 second, Chris, and please let me know if you can see my screen okay.
We still see the presentation.
Okay. How about now? I'm slowly bringing it up, so just bear with me. Okay. Can you see the screen?
Yes.
Okay, so here we see the CODESYS development environment in action. We talked about the fact that I don't need to deploy the web visualization for testing purposes. I can do it within the CODESYS development environment. Again, thanks to the wonderful team at both CODESYS and Keyence for getting this set up and tested and validated. We have the ability to reinitialize a drive. And as you noticed over here online, the drive is now reset. Press the reset button. You can see that there's no errors. Turn power on to the drive. The motor is now currently at standstill. And now I can jog that motor. Again, I apologize. I don't have a webcam in the lab. And so you can't physically see it, but that's okay because we have the ability to look at the positional data right here inside CODESYS. And when I press the reverse button, we can actually create motion on this device. You can see the velocity increase. The acceleration now is no longer accelerating, maximum velocity, and you can see the positional data change. Now, again, this is a game changer because now I'm going to demonstrate accessing the actual web page of the robot controller. And I am already running this in reverse, but now I'm going to shut it off from the web page. Multiple locations. And this is going to be a game changer because it shows the flexibility that this CODESYS development environment provides. And now we're going to jog this thing forward. And now you can see the counts decreasing. I'm going to stop that, and I'm going to bring up the robot page itself that shows the I/O mapping. They always warn me, don't do a live demonstration because you never know what can happen, but I say we give it a shot. So here we go, accessing our home page. This is the new interface for the R50IA controller. We go to our I/O. And you can see that I have the immediate stop, hold, save speed, and enable signals triggered. And you can see the four signals turn on inside the robot controller. Now I'd like to take the opportunity to demonstrate yet another interface. This is another screen that was developed by Jeff Nimps, and we will bring its robot homepage up. Again, this is the R50IA controller. And for security reasons, there's now passwords and logins for IoT reasons. And we'll take a look at the user operator panel for both inputs and outputs. And move this out to the side. So in this, we can actually control the override speed. So if you notice on the left-hand side, as we are operating the web visualization, you can see how we're changing dynamically on the robot controller the speed. I can put the robot into hold condition, and if you look at the right, it'll drop out the hold signal. The motion gets held. We'll clear that real quickly. Now I'm going to issue an immediate stop to the robot, which is going to put it into a fault condition. And then I can reset the faults using my web visualization, and now the controller is reset. At the same time, we were controlling the inputs. You can see the status lights of the UOPS. So if I create that e-stop condition, you see we're in a faulted condition and that the program is paused, which matches our user outputs from the robot controller. And then as soon as we reset it, I am now back into command enabled. The system is ready and the program is paused.